everyone. Today we would like to talk about our unit number 5, application layer. So what are the topics that we would like to focus in this particular unit is principle of network application, in which we will discuss network application architecture, process communicating, the transport services available to the application. So we would like to understand what are the different applications and what are the different kinds of transport services expected from those applications. Then we would move ahead for the various application layer protocols. The first among them is transport services provided by file transfer protocol. So we'll understand what is the file transfer protocol commands, and file transfer protocol replies. The, then we would move ahead for the second application called electronic mail in the internet, in which we would learn about a protocol called simple mail transfer protocol in comparison with HTTP. Then we would try to understand the next protocol called domain name service. In today's world, with the popularity of internet, we will try to understand how we are able to create various websites, or how the domain pages for the various websites are created. And one of the major protocol involved here is called domain name service. So what are the services provided by DNS? The overview of how a DNS works, and the DNS records a message. The application layer is basically responsible for providing services to the users. So what are the services provided by application layer, and how does it provide those services? Let's have a quick understanding. As mentioned in our previous slide, we were talking about that application layer is intended to provide services to the users. So here a user, which we call it as a human program, we would like to take the services of the application layer. So to take this service of application layer, it would be using one of the various available application layer protocols, through which it will be able to generate certain data, and to this data we are going to add a header and forward it to the presentation layer. Similarly, at the receiver side, the data will be forwarded from the presentation layer to the application layer, in which it consists of header as well as the data. So we'll try to remove the header content, and this data will be forwarded to the user. Right. So here you have your OSI model compared with TCP/IP model. We know that in OSI model we talk about the functionality of the layers, whereas in the TCP/IP model we will be referring about the protocols. So referring to our TCP/IP model, the major used application layer protocols are SMTP, FTP, HTTP, DNS, Simple Network Management Protocol, and remote login we are using an application protocol called Telnet. Already we have learned in our previous units about the protocols like TCP and UDP, which are a part of transport layer, and IP, ICMP, IGMP, RARP and ARP, which are a part of network layer protocols. In data link, we were discussing about some protocols like HDLC and PPP protocols. Let's have a quick understanding of the various types of application layer protocols. In this unit, we will be trying to focus on the conceptual implementation aspects of the network application protocols. Then what are the different transport layer service models we have? What do you mean by a client server paradigm? And then what do you mean by a peer-to-peer paradigm? After understanding these different types of models and the paradigms, we will be understanding about various protocols by examining the most popular application layer protocols like HTTP, FTP, SMTP and DNS. Right. So let's have some of the networking apps which we are using in our daily life, which includes email. We use SMTP. For web pages, we use DNS and HTTP. Then we have for text messaging network apps, remote login. We were discussing about Telnet. Then peer-to-peer file sharing like ShareIt, or you can find Bluetooth apps. Multi-user network games, and streamed stored videos like we use applications like Netflix, YouTube to use the stored videos. Then we have voice over internet protocol. A best example is a Skype call or a WhatsApp call. Then you have a real-time video conferencing. In this recent this lockdown and work from home culture, you could find more of these applications, social networking and so on. All these are the different networking apps which we are referring. Right. So how do we create a network app? So we have been just mentioning about what are the different network apps. Let me talk about a simple browsing a page, right? So here you could find in the screen we have different systems which are trying to access a particular web page. Now, the two entities which are involved here is the web server software, which actually contains the content, and our browser software on which we are trying to access that particular web page. So there need to be a communication between the web server software and this browser software. In between the end user and the server where we have this web page, we have various network connecting or network core devices. For the network core devices, we do not need to run these applications, and applications on the end system allow for rapid application development propagation. So the end device, we need this running of software, so but in the connecting devices, this is not required. The various application software architectures which have been in use are categorized into three types. The first one is called as client-server architecture, which is one of the most popular architecture. Then we have a peer-to-peer architecture, and then we have the hybrid of that is the combination of client-server architecture and peer-to-peer architecture. Let's have a quick understanding of what is a client-server architecture. Before I try to explain you this, let me tell you most of the applications which we are using in our daily life or the networking applications which we use related with this client-server architecture. Now, in simple, a server is a one where the actual content or the data has been available, like our Gmail servers, or you can talk about Facebook servers. And we as a client of that particular application, we are referred as a client and we want to use those services. So what is exactly a server here? The server is always on the host, means it is always active because it's not just one client. It was always number of clients who try to use the service of the server. So it is always on the host and it is allotted with a permanent IP address, because generally it will be in fixed place and it will be allotted with a permanent IP. And there will be data centers for the servers for the scaling purpose. As more and more the users increased, to support those users, we will be providing data centers for our server architecture. In coming to the client will be the one who is trying to communicate with the server. For instance, I want to access my email, I need to log into it. So that is where I am the client trying to communicate with my mail server. I may be not continuously connected. Sometimes I want to use, for instance, in some apps don't use continuously. Whenever I want to log in, like a bank server or a bank net banking. So I try to log in whenever I need a service. So I'm being intermittently connected. So I will be allotted dynamic IP address. For instance, I'm here trying to access on my mobile phone. Sometimes I use my mobile data, which is having a particular IP address. But in case if I'm trying to connect to different Wi-Fi's at different times, so I will be having a different types of dynamic IP address. And generally in client server architecture, the two clients will not be directly communicating, they will be communicating through this server. Let's talk the second type of architecture called peer-to-peer architecture. Now what do we mean by a term called peer? Any individual device who is trying to connect themselves. We know that peers refers to the same levels, right? So two devices in the network, when they are trying to communicate with each other without using the service of a client server, we call it as a peer-to-peer architecture. So they will not be no always on the server, means that they are not trying to use the service of the server. Arbitrary end systems directly communicate. What are the two arbitrary systems? The two systems which have been shown here, the two systems here, or these two systems, or you can find another two systems. Here they are trying to communicate directly without using the service of the server. Then we refer it as a peer-to-peer architecture. The peers request service from the other peers, provide service in returns to other peers. Now I won't like to communicate with one another peer, so I directly send my request or my data, and then I will ask him in return to send his data, so that we will be updated. So self-scalability, the new peers bring in new service capacity. What do you mean by this is, for instance, I have 2 points with me and I have shared it to my friend and he have 2 new points. When he shares, so I will be able to get 4 points from my side. The same time my friend also will be added with 4 different points. So this helps in upgrading ourselves. It will be helping in providing new service demands. The peers are intermittently connected and they change IP address. For instance, now I have been allotted with one particular IP address. When I move from that place, it might be allotted with another IP address. So it's a complex management architecture. So far, we were discussing about client server architecture and peer-to-peer architecture. Let's now try to discuss about a combination of this client-server architecture and peer-to-peer architecture. So here we have this architecture which is a combination of both the categories. So the first application which is using this hybrid architecture is Skype. So here basically a Skype is an application referred to voice over internet protocol. So we are making a voice call using an internet protocol, that is what VoIP, and Skype is one of those kind of application. It's a peer-to-peer application which is trying to connect two users. Here, what is the role of the centralized server, which we are referring it as client server? They are used to find the address of the remote party. Whereas the two end parties, once the address of the two parties are known, the server will not be involved and the two pairs will be involved in direct connection. And there is no more role of the server. Second application which is related with hybrid kind of architecture is instant messaging. We have a number of instant messaging apps. Generally, we have this chatting between the two users whom we refer it as a peer-to-peer. And what is the role of this server? That is a centralized service. So client's presence, detection and location will be done by the server. Once it is done, the chatting between the users will be direct. So it will be a peer-to-peer. So generally what we have to do is every user, that is every peer, has to register its IP address with the central server. So when it comes on, so this will help to detect its presence so that any other person would like to communicate will be able to do. The users contact the central server to find the IP address of its buddies. For instance, I want to communicate with the other colleague. First, I will approach the central server to know his IP address, and once we know, we are able to directly communicate with each other. Right. Now let's discuss the next topic called as process to process communicating. Before we understand this, let's try to understand what do you mean by a term called process. So process refers to a program running within the host. So every host, which we call it as a peer or a node, will be having certain program running within itself. That is called process. If two processes belong to the same host and they are trying to communicate with each other, that is, so the two processes which would like to communicate are inside the same device, we call it as inter-process communication. But when the two processes which would try to communicate are on two other devices, then they try to communicate using certain exchange messages. So if within the device two processes communicate, inter-process communication, and when it is between the two devices, then we are exchanging certain messages. Now, what do we mean by the two processes called client process and the server process? The client process is the one which is trying to initiate the communication. For instance, I am trying to access my Gmail on my system. So I need to log in. So first I will try to access the Gmail web page and I try to enter it and try to move to the server side. So this is the client process. Once I am connected, so the process that is waiting to be contacted. For instance, the Gmail server is waiting when I would make this request. So the Gmail server process will be referred as server process, and my request to connect to the Gmail is referred as a client process. Okay, suppose we have been just discussing about there are certain applications dealing with peer-to-peer application architecture, but in that also you will have both client process as well as the server process. So client process, which we just discussed about instant messaging and Skype. So both client process as well as the service process will be involved in those communications. Right. So let's try to understand the next important term called as sockets. Now what do you mean by sockets and what is the role of the sockets in this network? Now let us look at this TCP IP model. We know that the application layer is the one which is actually generating the data, and inside the application layer there is a process which is generating the process to send the data, which we have just discussed, like client process and server process. Now the application layer generally takes the service of the transport layer, and here the process which is generating the data will forward to the transport layer using something called as a very important term called socket. Now socket is something where it's something like an entrance door. For instance, whatever the data that has to move from the process of application layer to the transport layer will have to be forwarded through this socket. So sending process shows this message through this socket, and sending process relies on this transport layer infrastructure on the other side of the door to deliver the message to the socket at the receiving process. So what we could observe is the sending process through the socket would forward the data to the transport layer, and at the receiving end from the transport layer through the socket, the data will be forwarded to the application layer process, and this application layer process will be controlled by the app developer. Right. So what are the addresses do we require for implementing this application process? So if I am connected to internet, is it sufficient? If the IP address is just sufficient for my making the application process, then the answer is no. So IP address will be helping us to connect ourselves to an internet, and that will be identified. What is the IP address refers to the internet address which we are connected. But within the device, we may be using multiple processes. So each process will be different from other. So how do we identify different processes within the system is for each process we are going to allocate an particular port number. So we require both addresses. One is IP address as well as the port numbers. For instance, you want to access a particular web page, then you not only need to mention about the IP address of that web page, but also we need to able to mention the particular port number of it. Then only we will be able to send the message. So IP address and port address plays a crucial role in accessing the application process. Right. So let's now discuss about what is the application layer protocol and what is actually tries to define. Generally, what do you mean by protocol? Protocol refers to set of rules and regulations which will be defining the communication. Basically, a protocol consists of syntax, semantics, and tagging. So the application layer protocol which we are talking about consists of two types of messages. One is called request message and the other one is called response message. And each of this either a request message or a response message has a syntax which consists of various fields. So syntax talks about what are the fields available in each message, and the semantics talks about what is the meaning of each of this field and what is their function. So the rules for when and how the process will be sent and respond to the messages will be explained by the rules which are a part of the message semantics. So what are the different open protocols which we have in application layer? First, let me try to understand what is an open protocol. These are the ones which are defined in the ready for comments. It will be allowing us for the interoperability feature. And the examples of open layer protocols are HTTP and simple mail transfer protocols. And coming to the second category of application layer protocol called proprietary protocols, the examples for this is Skype. Right. We were mentioning that the application layer will be taking the service of transport layer. So what kind of services an application layer expects from the transport layer? The first and most important one is the data integrity. So what do we understand by a term called data integrity is for some applications like file transfer applications or web transactions, we don't want to miss any data. At the same time, we want a reliability in the data transmission so that that information will not be lost to anyone else. So first important factor is reliability, that is the data integrity is one of the transport layer service requirements from the application layer. For applications like audio applications, we don't want this particular feature, but applications like file transfer or a net banking kind of things, we expect this data integrity to be included. The second feature is about the timing. Some applications will not be accepting delay in the transmission, whereas some applications will allow the delay. So applications like our VoIP services or interactive games or online video games, we don't want delay, but there are certain applications which can accept the delay in the transmission. So the second transport service requirement is the timing and the delay factor. The third one is important for some of the data applications which is referred as throughput. Here what exactly the application layer expects is not only a reliable data transfer, but it wants to ensure transport layer to ensure there is a minimum loss of packets so that the effective throughput will be high. The applications which are expecting this high throughput are really something like data communication applications, and certain other apps make use of whatever the throughput they get. They are not so strict about the throughput, but they just expect a good transmission rate. but some applications will require a maximum throughput. So the last kind of transport layer service expected is security, which we expect encryption and data protection for our data transmission. So reliability, delay, minimum delay, throughput, and security are the services which a application layer expects from the transport layer. Right. Now let's look at various applications which we are using in our life and what are the kind of transport layer services they expect. For instance, first we talk about file transfer, where we have the data in form of files. Here we don't want any data loss, but throughput is minimum or it is elastic. For sometimes it may be allowing a few bits of drop, but we don't want much data loss. And time sensitive is not much a factor. It may take a delay of time, but it will not impact on the quality of the data received. So for file transfer, data loss and throughput is more important compared with time sensitive files. The same case with emails, where we don't want any data loss or the throughput is to be best, but delay will not be much affecting the email received. The web documents, the same category. Here the data loss is not much required. Data loss is to be minimum. The throughput has to be maximum, and the time sensitiveness, a mail delayed by certain time will not impact on the quality. Now coming to the next applications which are delay sensitive, the real-time audio video, where you are find some data is lost or throughput is a bit low, it is fine, but we don't want time sensitive delay here. The same case with stored audio videos, where the loss can be allowed but delay should be minimum. The interactive games, the stored audio videos, and the text messaging again is expecting the good throughput and minimum data loss, and the time delay can be accepted. So for this kind of 4 different kind of services like reliability, security, then about time delay, and we were talking in the previous slides. So which protocols will be suitable for which transport layer application will be suitable for the particular applications. When you want a reliability in the data transmission, the first protocol which you have been referring from transport layer is called TCP. So the TCP is one of the transport layer protocol which will provide reliable transports between the sending and receiving process. It will be implementing a flow control mechanism so that there is no overflow of data, and in case of any network congestion, it will be able to implement certain congestion control mechanisms. And before the data transmission, the TCP is a protocol which will be implementing a connection oriented mechanism, but the TCP cannot be implementing this timing guarantee or security protocol. But when your application doesn't require reliability, doesn't require any connection, data can be transmitted in any way, but it wants a minimum delay. So if the delay is a crucial factor, then we are going to opt for a transport layer protocol called UDP protocol. And what are the services provided by the user datagram protocol? Or unreliable data transfer. So it doesn't guarantee you any reliability, and it does not provide any flow control. It does not provide congestion control, and does not guarantee the throughput. And most important thing is the delay will be minimum. So that is the reason why for some of the applications where the real-time applications, we prefer UDP over TCP. We had a recent examination in which they have asked, though the TCP is a reliable protocol, why do we require more of the applications require UDP? The reason is simple. When applications are time sensitive, they don't want any kind of delay, but they are acceptable for the low throughput or lower throughput or less data loss. Then those kind of applications require the service of UDP protocol compared with transporter transmission control protocol. So let's look at the applications and what are the transport layer protocols used. For email, the application layer protocol which is concerned is SMTP, and the transport layer protocol which we are using for it is TCP. And for the next application, which is remote login, that application layer protocol we are using is Telnet, and the transport layer protocol which is concerned is TCP. For an application like opening a web page, we use a application layer protocol called HTTP, and the transport layer protocol used is TCP. Then for file transfer, which application, we use a protocol called file transfer protocol, and the transport layer protocol which is concerned with it is TCP. And now comes the real-time applications like streaming multimedia, for which the application layer protocols used is real-time transport protocol or HTTP, for which you can use either TCP or UDP. but more preference is UDP. For VoIP kind of services where the data loss doesn't create much problem, we have protocols like SIP, Session Initiation Protocol, or Real-Time Transport Protocol, for which we are using transport layer protocols, either TCP or UDP. So these are the various internet applications, the concerned application layer protocols, and the related transport layer. So far we have been talking about TCP and UDP, its futures, but we have not discussed about how do we provide security for this applications through this transport layer protocols. So either TCP nor UDP does not provide any service security. So to implement security for application layer protocols, we are using a special protocol called Secure Socket Layer, in simple called as SSL. SSL stands for Secure Socket Layer. Secure Socket Layer. Okay, so both TCP and UDP does not provide any encryption, and it will not create any password kind of protection for the sockets and the implementation. So we are using a special application layer protocol called Secure Socket Layer. Okay, so Secure Socket Layer actually provides the encryption for the TCP connection. It implements the data integrity and endpoint authentication. The Secure Socket Layer is present at the application layer, and it will be using the secure socket libraries to talk with the TCP. So all this security applications which are related security point of applications will be implemented by a special protocol called Secure Socket Layer, which supports both TCP and UDP. So we'll discuss the next topic, web page and HTTP, in the next video.